Section 4.5 is about the polynomial equations. We're going to continue using the things that we've learned about division and end behavior from the beginning of the chapter to kind of tie things together. So for solving polynomial equations, one of the things that we're going to learn about is the rational zero theorem, which basically narrows down the rational types of possible solutions you have for equations. And also I can use the zeros to write the polynomial function. So if 5 is one of the zeros, you'll know that x minus 5 is the solution, but it goes a little bit deeper than that as well. So first of all, this looks like a messy little thing, but the rational root theorem basically says for a polynomial with integer coefficients, then every rational solution will look like this. It'll look like the factors of the constant, that's the number by itself at the very end, divided by the factors of the leading coefficient. Factors of the constant, you should write this down. Pause the video and write this down, the P over Q part. For a rational root theorem, a rational zero theorem would say the P value, the constant, values of the factors of the constant divided by the factors of the leading coefficient are the only possible rational solutions for this kind of function if they have integer coefficients. So for instance, if I was to list the possible rational roots or rational zeros for this one, I would be taking a look at 3, that's the Q value, and here's the P value, the constant divided by the leading coefficient. And this is working because 3, 7, negative 22, and negative 8 are all integer values. If I had some kind of crazy stuff in there like the square root of 18 or square root of 19 or something like that, it wouldn't work. So if we wanted to make a list, we would take a list. We would get the list of the possible factors for 8, 1, 2, 4, and 8 divided by the factors of 3. Well, the factors of 3, of course, are just 1 and 3. So I could have all these over 1, which is why I just already wrote them. And then I could do all of them over 3. So plus and minus 1/3, plus and minus 2/3, plus and minus 4/3, and plus and minus 8/3. Now you might think, well, this is a very long list. 1, 2, 3, 4, 8, 16 possible rational roots. But the fact is that if you didn't know this list, then the list would be infinite. I mean, we would have an infinite possibilities for this thing. So I'm going to show you how you narrow down how to find solutions for an equation based on this list, and also we can use graphing sometimes too. So let's see how that works. So I'm going to take the same thing, and I'm going to say, well, I want to figure out what goes into this, what the solutions are, find all the zeros, and then sketch it. So for instance, on this one, I would probably take that list, look at that list, and I would go through using synthetic division until I found some that work. So for instance, if I tried 1, 3, 10, 10, negative 12, negative 12, negative 20, I know that doesn't work. That's not a 0 because there's a negative 20 there. It's supposed to be 0 if it works, right? So I'd keep on going through until I found one that gave me a 0 in the end. So I could try 2 next. I'm just guessing, right? So 3 times 2 is 6. Then we have 26. Then we have 4, 8, and 0. And lo and behold, this one has a remainder of 0. Therefore, 2 is one of my answers. So 2 works. And what's even better is that now I've got 3x squared plus 13x plus 4, which is an even smaller thing. I can even try to factor this if I want to, or I can continue using synthetic division. But if I was looking at my list of all those numbers that I had before, now I have a smaller list because I can't use 8 as one of the possible factors. 1/3, 2/3, 4/3, and 8/3. We can't use those anymore. Now we might use, and remember this is plus and minus, I might have another 2 in there, but I doubt it. So I can continue factoring this thing, or I can continue using synthetic division, or I can try to factor it. It's not that hard to factor 3x plus something and x plus something, and all of them are positive. And by the way, the other thing I'd say at this point is that there's no way I'm going to get a 0 over here unless I have a negative number that I'm using for synthetic, because how is that possibly going to add up to 0 if I don't have a negative in there? So that narrows it down to even fewer, 1, 2, 4, 1/3, 2/3, 4/3. So I'm just going to use negative numbers. Let's see, it'd be -12, 1, -4, and sure enough, that one works. 4 works. And then 3x plus 1. Notice that I started with 3x to the third, now I have 3x to the squared, and 3x to the first power. This one gives me -1/3 if I solve that one for 0. So now I've got my 3 zeros. And if I was just going to make a sketch for this thing, it might look like this. Let's talk about how this is going to work. And this is kind of like putting everything together. I know that there's a 0 at +2. It goes through the graph right here. It goes through the graph at -4 over here. And it goes through at -1/3, which is kind of in the middle there. It goes through the y-axis at -8, because if you put a 0 in for x, then you're going to have -8. Now, that might not look like a lot of information, but it's a ton of information, because remember, we also know that the leading coefficient is odd, and it's a positive, or the highest degree is 3, which is odd, and the number in the front is positive. That tells me the end behavior is that it starts at the bottom left and it goes to the top right. Well, that means there really can't be a whole lot that can go on here. If I start over here and go down through -1/3, but I have to go through -8 and go up this way, I'm started at the bottom left and I'm ending at the top right. Now, I don't know how steep this thing's going to be. It might go really far up in the second quadrant. I don't know, but I'm just trying to get a feel for what the graph looks like. And that's my goal for you, is to get a feel for what a graph looks like without having to rely on a calculator or computer all the time. So this is how you find zeros, by narrowing down what the possible zeros are and then plugging them into synthetic division, probably to narrow down. Even after you get the first one, I could have factored 3x squared plus 13x plus 4 into 2 parentheses, but I'm solving. That means to solve this, I get those 3 numbers, the 2, -4, and -1/3. And then the last part is sketching it. So let's see what's next. I could do another example. Why don't you try this one first, and then, or let's talk about this one a different way. I'll go back and do another way for our examples later on. So there's an awful lot of possibilities, but first of all, pause and list the possible rational zeros before we do anything. So pause and just make that list of the plus and minus numbers. Okay, I'm going to get the factors of 20. 1, 2, 4, 5, 10, and 20 go into 20, plus and minus all of them. And then the leading coefficient is 2, so I'm going to divide these all by 2. Now, 1 divided by 2 is 1/2, but 2 divided by 2 is already on the list. 4 divided by 2 is already on the list. 5 divided by 2 is not on the list yet, 2.5. 10 divided by 2 is 5, so that's already taken care of. 20 divided by 2 is 10, so that's already taken care of. So 1, 2, 3, 4, 5, 6, 7, 8 possibilities where only these 1/2 and 5/2 are fractions. So those are my possible zeros. Now let's keep those in mind, because what I've done on this one is I thought we could go through. I thought I had a sketch on. I guess I'll do it later. So I thought I had a sketch on Desmos for this one. Let's. I guess we'll go through and try it the same way. So let me make that list again. 1, 2, 4, 5, 10, 20, 1/2, 5/2. And remember that I can use both positive and negative. Now I've done a little research on this one, and I think one of the answers is -2. So let's try that one. You might do these in a different order, and that's fine. But let's see what happens with -2. 2, -4, -15, 30, 43, 86. I thought I did my research on it, but I guess not, because it doesn't look like it works out very well at all, does it? It doesn't. That's never going to work out to be 20. So let's try again. I thought -2 worked, but I've been known to make mistakes before. So let's try another number. Or maybe you got a number. Let's see what you got. How about if we try 5? 5 is on the list. All right, let's see. 2, 10, negative 1, negative 5, 8, 40, negative 4, negative 20, 0. Okay, 5 works, so that's nice. And now I've got something that looks like this. Now, automatically, I'm drawn to the fact that 2, 1, 8, 4, and 2, negative 1, 8, negative 4, they look to me like they're in the same ratio. 2 to 1, 8 to 4 is the same as 2 to 1. So instead of continuing with synthetic division, I'm thinking that I'm going to put these in a box. Let's see. 2x to the third minus 1x squared, 8x minus 4. And let's see. We've got, going across, the common factor is x squared. This one's 2x. This one over here is 4. And this one's negative 1. Sure enough, it worked out that way. So 2x minus 1 gives me 1/2 as another factor. That's on the list. But x squared plus 4 equals 0. That's not going to be anything on the list, is it? X squared equals negative 4. We take the square root of both sides. We're going to get plus or minus 2i. So I think if I graph this one, I'm going to have 2 places where it crosses the x-axis. And this imaginary stuff is not going to be where it crosses the x-axis. So if I was going to make a quick sketch of this, try. I know that what I'll be looking at is positive 5 and negative 1/2, or positive 1/2. There we go. I know it has a y-intercept of positive 20, which is way high. And those are the only 2 places it crosses the x-axis. The other thing is that it's even. This is even, the power is even, and the number in front is positive. So it's positive even, which is like a parabola, means it goes up, up. So it's going to go through that point, and then it's going to go something like that. I don't know, maybe it'll have some squiggles in it, but it's going to do something that looks like that. All right, so not the best method in the world, but I wanted to show you one where you might be using factoring by grouping. Even if I hadn't used factoring by grouping, having the next problem be 2x to the third plus 1x squared plus 8x minus 4, that 4 right there cut off the possibilities of those guys being factors and this being factors. So I'm only left with plus and minus 1, 2, 4, and 1/2, because that 4, I could apply the same the zero thing with it. All right. Now, I think that we'll cut the video here, so we'll have the notes in 2 parts.